Hello friends, welcome to SY Academy. In this video, we will going to discuss about the CAP theorem, which is quite common and asked a lot of times. It is also called as Brewer's theorem. Please note this on the basis of the one who gave this theorem. Please note that this is applicable for distributed systems. Okay. And what is a distributed system? A distributed system is a collection of independent nodes or independent servers or independent computers that work together, right? S1, S2, S3, S4. And let's say this is your account system, right? Account system. And in your account system, you have four servers or four computers, nodes, right? Multiple ways you can write all means the same computer, node, server. Some people also use pods. I don't want to go into detail, but you can also take it in a very similar manner here. And it appears to work as a single system. For example, you have a human body, right? You have heart, you have kidneys, you have liver, brain, and everything, right? A lot of systems are there. You have a distributed system in your body, but all are working together to make you work. And it looks like a single person at the end of the day. Nobody says that, oh, your heart is saying this, oh, your liver is doing this, your kidney is doing this, right? So it is similar to that. It is a distributed system. And each node, again, please note, this is a node. So people who are confused, this is a node. Node means simple computer, right? Each node is having its own memory and processor. It communicates with other nodes. That means S1 is talking with S2 and share resources and computational resources. There are multiple models. Again, I'm not going into details, but there is a possibility that S1, S2, S3, S4 all are talking to one common database, one common MySQL, right? So this is an example of distributed system that multiple nodes are there, right? Multiple nodes. Even this database, right? It could be of multiple nodes, like N1, N2, N3, all have MySQL, right? All could have Cassandra if you are using Cassandra, right? All could be having Cassandra, but they are multiple nodes. So this is called as a distributed system. So what CAP theorem is saying, in a distributed system, you can only guarantee two out of three things. It is saying either you can get consistency or you can get availability or you can get partition tolerance. That's why it is called as CAP, C-A-P, right? Consistency, availability, and partition tolerance. This is almost not possible, right? Please note, this is not possible all the time is a right word, right? But most of the time you could have consistency, availability, and partition tolerance, right? What it's trying to say is you can either choose this one, you can either choose this two, you can either choose this three. That's what you need to decide on the basis of your system. Hope it is clear. If things are not clear right now, just keep one thing in mind. In a distributed system, you can either have consistency, availability or partition tolerance, consistency and partition tolerance. Now you could be asking what is partition tolerance, what is consistency? And some people also get confused between this consistency and the consistency in the asset. Please note the consistency in the asset properties, right? ACID asset. This consistency is different from this consistency. Let's go into the definitions. Consistency means every read receives the most recent write or error. Let's say, let's say your amount or wallet amount was 500. Now you added some money and it is increased to 600 bucks, right? And let's say your database is having multiple systems, multiple nodes, right? Like S1, S2, S3. So your data is updated here from 500 to 600, but it is only 500 here and it is 600 here. Such kind of system is not consistent. Such kind of system is not consistent. Please note in asset, for which I have already made one video, you can see that C means consistency. That means your state remains the same, right? If you have any foreign constraint, if you have some triggers or some indexes or anything in your databases, that will remain consistent even after the transaction, and that is called as consistency in asset. The consistency in CAP theorem means all your nodes should have the right or most recent entry, and if somebody is asking you the value either from S1, S2, S3, it should give 600. If somebody is giving 600, somebody is giving 500, then your system is not consistent. As you can understand, this is very important in banking applications, right? Consistency is very important in banking application. Just imagine you are getting values sometimes 500, sometimes 600. You will lose your trust in the banking system. That is why remember that in banking system or financial systems, any financial system, the consistency is most important. If you have worked in financial institutions, if consistency is not there, then your job is on the line. So it's like reading from a single up-to-date copy of data. It should look like that there is only one server, right? There is only one node, correct? Now let's look into the availability. Availability means every request that you are sending, you are getting response. Whenever you are sending a request, you are getting response. For example, if you are sending a request, you are getting 500, sometimes you are getting 600, sometimes you are getting 500, 600. This system is not consistent, but this system is available, right? Are you getting my point? Similarly, let's take another example. Let's say your system is made in such a way that if the record is not updated, you will not give the output. That means you will only give 600. Otherwise, you will give internal server error or system not available, 400 not found, right? Let's say you are giving some error. In this case, your system is not available. Though it is consistent, but it is not available, right? So, system is always responsive. As you can see, banking system needs to be consistent, but when you have to choose between consistency and availability, you always choose consistency in the banking system. Let's take an example where where availability is most important, but consistency can be ignored. It's social media websites. Let's say you wrote one comment, right? You wrote one comment, and that comment is, I mean, let's say let's take better example. Let's say you are liking post, right? Now the data is 400 and then 500. I mean, people are keep on liking it, 600, 700. Let's say your system is sometime returning 500 instead of 600. This is fine. I know this is not best solution, but this is fine. At least you are getting some output. Let's take another example, OTT application. Let's say you are showing details on your home page that these movies are there. Let's say due to some reason, one movie is not available, right? One movie is not available, right? But instead of not returning anything, you are returning all other movies. Let's take one example very precisely. Let's say your system is having 10 movies and one movie is not updated. So your system is returning 9 only. This is fine. This is fine. Hope you're getting my point. Let's say one a movie which is F1 race. I mean, taking one random example. F1 race is not available in your system due to some reason, due to inconsistency in your system. But you are returning all 9 movies on your home page. This is acceptable. That means in OTT application, your availability is more important than consistency. Okay, in OTT system. Now let's understand what is partition tolerance. It is asked a lot of times and people remain confused also. What is consistency? What is partition tolerance? Partition tolerance says that the system continues to operate despite network failures or loss of communication between the nodes. And it is very essential in the distributed system. So that means your system continues to operate. Let's say you have S1, S2, S3, S4 nodes, right? And let's say your one of the node, which is S2, goes down. Then you have three nodes, S1, S2, sorry, S1, S3, S4. You have three nodes remaining, and one node is not there. Even then, if your system is continuing to work, that means your system is partition tolerant. And it is very important. You always have multiple machines in your distributed system. Let's take one example of big companies such as Facebook. They have thousands of servers. Let's say if their five machines are not working, that does not mean that Facebook will stop working. They have 995 machines remaining there, right? So that means they need to be partition tolerant. Hope you are getting this point. Your system continues to work despite network failures. And network failures are quite common. They keep on happening due to multiple reasons, which I'm not going here. Your system memory has overflown, or maybe some node is damaged physically, right? These are physical nodes, hardware has damaged, right? Still your system is working. That means it is partition tolerant. These 3 points are very clear. Now there is a trade-off. You need to pick two out of three. Okay. So you must tolerate partition tolerance in distributed system. So the real world choice is usually between two. Either you need to choose consistency and partition tolerance. That means your data should be consistent. It should always give 600 instead of 500 in our example. Partition tolerance means your system should continue to work even your one node is going down. So they prioritize correct data over uptime. Data should be correct. Example, banking system. Let me highlight this point one more time. In a banking system, it is always good to say that your system is not available instead of giving wrong response, right? If you are saying that system is unavailable, right, to your user, instead of giving incorrect value, which is 500 wallet amount, it is better. Remember this point. Hope you're getting this point. You can write in the comment section. The best examples of such systems where consistency and partition tolerance both are there are HBase and MongoDB, right? Now let's take another example where availability and partition tolerance are more important. They prioritize response over accuracy. I gave you example of OTT system. I gave you example of social media, right? CouchDB and Cassandra are those databases which supports availability over consistency, right? Hope you are getting this point. Now let's go to consistency and availability where both are there. Theoretically possible only when there is no partition, not practical in real world distributed systems. So what we are trying to say is, let's say we have S1, S2, S3, S4, four servers. If you have such a system, then you cannot have consistency and availability both, right? Because you have partition. That means your data is partitioned. What if this goes down, right? What will happen then? You need to take a call whether you want to give the consistent data or not, or you want to give available data or not. Let's say if this goes down, then there is a choice that you will say that, okay, I will not be available. Till the point the data in S3 is consistent, you can take this decision. Second decision you can take is, okay, I may not be consistent. Your question could be why it is not consistent when S1, S2, S4 are there. Please note that when S3 will come up, right? When it will come up, it will try to get the updated data from S1, S2, S3, right? Usually there is a leader. That means either S1 could be a leader, S2 could be a leader, or S4 could be a leader. If S3 was a leader, then they will elect a new leader, which could be S2, right? So what I'm trying to say is when S3 will come up again, it will try to fetch the recent data. And during that moment of time, your data might not be consistent because S3 will take some time to become consistent with S1, S2, S4. It could be seconds, it could be hours, it could be days also. Yeah, that is the bad truth of IT systems. Sometimes it could take a day also to get the correct data if the data is too huge. So what I'm trying to say is if you have partition tolerance, that means if you have multiple nodes, you cannot have consistency and availability. One example where you could have consistency and availability both is if you have single MySQL server. If you have single MySQL server, you can have consistency and availability both. Now let's take real world examples where you can have all those consistency and availability. This could be asked in the interview. Also, you should know, and this will allow you to choose the right database in the interviews and while designing your system. MongoDB, you have consistency and partition tolerance. It loses availability during partitions. Please note it will lose availability because it focuses on consistency. In Cassandra, it's availability and the partition tolerance, which are more important. And sometimes consistency takes a toll. Please note if there is no partition tolerance, that means your system is working totally fine. Then you could have all three together. That means availability, consistency, and partition tolerance. That is there in most of the cases. right? But we are discussing of some of the scenarios. Also, please note Redis, it is consistent and partition tolerant. It prioritizes consistency over availability. Please note DynamoDB, this is tunable. Tunable means you can decide whether you want to keep availability more or consistency more. Please note that similar situation is possible in Mongo and Cassandra also, that you can change consistency and availability as per your needs. So you can adjust this consistency, and also a zookeeper, which is another example. You focus on consistency and the partition tolerance, and it is used for the leader election. It needs stronger. So hope these things are clear. Let's finish our lecture with few things. Distributed system usually aim for eventual consistency to balance availability and partition tolerance. Eventual consistency means your system will become eventually consistent. That means you will have the movie F1 race, which was not available in some of the databases. Eventually, it will be available. That is why it is called as eventual consistency. Tunable consistency like Cassandra or DynamoDB allow developers to configure based on user case. So you can decide whether you want to focus on availability or consistency. And you need to choose understanding, you need to understand your system, right? While taking decision, you need to discuss with product managers and other stakeholders. For example, in banking system, it is always a strong consistency. In social media, it is eventual consistency, but your social media should always be available. What if Facebook goes down? Nobody will like it. You will lose money. Common misconceptions. CAP is not a law, but it is a guiding principle. Please note, it guides you to take right decisions. It does not mean you cannot get all three temporarily, but guarantee under failure are restricted. I'm again repeating the same point. You could have consistency, availability, and partition tolerance sometimes, but you cannot have it all the time, right? This is important to understand. Many modern systems you gracefully degrade and offer tunable options. What this line means is you can choose what do you want to achieve. I mean, you can choose you want availability, you want consistency, or what, right? Summary, I mean, CAP consistency, availability, and partition tolerance, you can only get 2 out of 3 in distributed system with network partitioning. Please note it is for a distributed system. If you have a single node, there is no point of consistency and availability. If it goes down and everything is down, there is no consistency, there is no availability. But usually in modern systems, you have distributed systems. You cannot work with one system. What if it goes down at any moment of time? Also, use case and business logic determine the trade-off, whether you want availability or consistency. Let's take one interview question and a fun fact. Which database is best according to the CAP theorem? Somebody could ask this. Please write this in the comment section that this actually checks you, right? Actually checks you how much do you understand CAP theorem, right? But the answer is it depends on the business requirement. Is uptime more important or accuracy or vice versa? This is the answer that you need to give. It depends on the business requirement, whether you want consistency. If it's a banking system, definitely you want consistency. That means availability can take a toll. Is uptime more important? That means in social media side, then of course availability is more important. Hope CAP theorem was clear to you. If there are any questions, please feel free to write in the comment section. Thank you.